Hi everyone, and welcome back to my channel, Dr. Coco's Medmonics. Today I'm going to be going over renal tubule physiology, and specifically I'm going to be going over a picture that I drew out, and this is the whole picture as far as like things that I found really high yield. First thing I want to go over, I don't know why, I think I'm the only human in the world who has this problem, but these purple arrows, I always get confused about like what direction things are going. And so first is filtered, so anything that comes through the arterioles that goes through the basement or the Bowman space is going to be a filtered substance. If it's getting reabsorbed, it's going from the Bowman space into the capillary. And I'm just gonna tell myself at this point, but I actually draw this picture with these arrows every single test I've ever taken, NBME, STEP, whatever, because I always forget what reabsorbed means. In my head, if you say, oh, the kidney reabsorbs something, it kind of feels like it's bringing something in, but no, it's going from the Bowman's to the capillary. And then when it's being secreted, it's going from the capillary back to the Bowman space. So everything is like in relation to the capillary. The capillary is absorbing it. The capillary is secreting it. But the way the question stems will talk about it, they'll say, oh, well, the kidney reabsorbed something or the kidney secreted something. And so I just have to go ahead and draw these out every single question. And then if it's getting peed out, it's going to be excreted, and that makes sense. Next we have the afferent arteriole, which is coming in, and the efferent going out, the distal convoluted tubule with the juxtaglomerular cells that are going to give off renin. This is just normal like anatomy, histology, whatever you want to call it. And the two things that I've gotten the most questions about is what happens when you constrict or dilate these different arterioles. And I like to write out PDA, kind of like public displays of affection, and then ACE, ACE. If you can write these both down, another thing I write down every single time I get a kidney question, it'll help a lot. So PDA is for prostaglandins dilating the afferent arteriole. And so if it dilates this afferent arteriole, you're going to get more fluid coming in, right? So you're going to have increased things that are going to get filtered, and you're going to get more plasma into this kidney. And so both the glomerular filtration rate and the renal plasma flow are both going to go up. And the formula for filtration fraction is GFR over renal plasma flow. So if both of these are going to go up, then the filtration fraction is going to stay the same. And so all this makes sense. I mean, if you open this up, that's going to lead to more fluid being able to go in. And because this efferent, like nothing's happening to it, you have all of this fluid going in, you're getting more fluid to the kidney, and you're also increasing the rate of filtration because you have more stuff in here to be filtered. And then, so if we know PDA, prostaglandins dilate the afferent, then what happens when you have a drug like an NSAID that blocks prostaglandin synthesis? Well, if you give an NSAID, it's going to do the exact opposite, right? We're blocking this dilation, so NSAIDs would constrict the efferent arteriole and therefore decrease the glomerular filtration and renal plasma flow. And if we come over here to ACE, ACE stands for angiotensin II constricting an efferent. And so if we constrict this efferent right here, we're going to have the same amount of fluid coming in, but it can't get out, right? And so that means that the renal plasma flow is going to go down. But because we have all of this fluid still in here, all this blood, you're going to be able to filter more because it's not going to be able to get out as easily, right? So you're going to have more time to filter down here. And so then your GFR is going to go up. And so if your GFR goes up and your renal plasma flow goes down, you're going to end up having an increase in your filtration fraction because of this formula right here. And so we know ACE is angiotensin II constricting the efferent. So what happens if you give an ACE inhibitor? Well, it's going to inhibit this constriction, right? So then we're going to have dilation of the efferent arteriole. And if you can really remember, what direction is filtered, what direction is reabsorbed, secreted, excreted, and then remember PDA and ACE, then you can get a lot of questions right as far as what's happening in the kidney. Are we filtering? Are we messing up the flow? Are we messing up the filtration fraction? And then also bringing in different types of drugs and what each drug does to each arteriole. Hopefully this helped you. This is a concept that was heavily tested on, NBME, Step U World, and just this quick little drawing helped me get all of those right. Hopefully this helped you, and if you liked this video, please like and subscribe to my channel. This is Dr. Coco.